Hello. Hello everyone. I think the stream is better now. Is this okay? I don't know. Let me check on my other phone. Let's refresh this page and see. Let's refresh this page. Let's see. Okay, this seems alright to me. I think this is okay. Although it's a bit slow, but I think we can manage with this now. All right, so today we're going to cover some interesting topic. This will be on how the compilation process works in a C program, and we'll also learn about the different ways what happens behind the scenes when you write a C code. So first of all, we are going to write a basic C program, and of course we'll be using Vim. So in my previous stream, I used Vim to do to demonstrate the basic usage of Vim, and we also used a few key combinations. Today we'll continue using Vim while we are learning C. Okay, so I just closed that tab. Sorry about that. Okay, I did not know what I did. So let me just increase this again. I'll seed into projects, and I'll seed into YouTube like this, and we'll clear this. Okay, that was not. This is how you clear the terminal. So 500. How much you want? 2,000. Are you driving the car? I'm not. No. I'm sorry, a second, please. Sorry guys, I'm back now. Okay, so we are going to continue learning with Vim. We are going to, so last week we learned how to write a basic C program, but we did not go into details, or I did not go into details about what actually happens when you write a C code. So I'll quickly output the content of this file, which is the hello.c file here. And we can see we have some C code here. Now this is what I want to get into. Over the week I've been trying to understand what actually goes on behind the scenes and how these different lines of code work together. Okay, sorry, let me just snap this here. Okay, so let's clear this terminal and open. I'll create a different folder. I'll call this folder BTS. So let's create a folder. We'll create a folder by typing mkdir. Let me see if this is clear enough on the screen. Yeah, it is. Okay, so mkdir BTS, right? So when we ls this, you can see we have the BTS folder here. So let's cd into the BTS folder. So cd BTS folder. So now inside this folder, we'll create a file and open the file in Vim. So I'll call this file vim hello.c. Okay, now this file is opened in Vim and we can start writing our C program. Now I also linked in the description this PDF or this page, right? It's called bj.us. It's a C. It contains C lectures, learning C programming lectures. So you can see the different explanations, and you can even go back to the content as well to see what's inside and move, to the topic that interests you. So let's start with writing a basic C program. So first of all, I mean, by default, what I've seen a lot of people do in C is to, first of all, let's go into the insert mode. As you can see below my terminal here, we are now in Vim, so we are in the insert mode. If I press escape, you go back to the normal mode. So we have insert and normal modes in Vim. So now let's go back to the insert mode. We are in the insert mode, which means we can type stuff, right, and they will show up on the screen. So let's first of all put a comment here. Sorry about that. I'll just put hello.c. So this is just based on convention. A lot of people put their the name of their file at the beginning of the file. I don't know why they do that, but this has no effect on your code. Actually, this is a comment and it does not hit your code. So the first thing we need to do is to write the there's a line called include, and then you put into brackets. So let's start. You put in a pound sign and you type include. I will explain what this does in a minute. So let's just continue with the code. So we'll put here stdio.h. Now this is called a header file, and I'll also explain what it does. So the next line is to actually write the I think it's called the entry function, right? So this int main and then putting void here. So you can do this int main, and then this is a function. So if you are familiar with other programming language, you would recognize this pattern, especially when languages like JavaScript, you put in some parentheses in front of the function and then followed by these curly braces. So here we'll type in our function. I'll just put printf, and then we'll say hello world chapter 2, or let me just put learning Vim and C chapter 2, right, which is the title of this stream. And then we'll put this semicolon here to end the program, right? And so people usually put this return 0, but I don't want to put that. The program can execute without it anyway. So let's just end it there. And then we can now exit Vim and go into the normal mode, right? I mean, we go into the normal mode by typing escape. Now you can see there's no longer insert here, and then we can begin to type in some stuff. So first of all, I'll need to save this file. So I'll save it by simply saying write, just type in W, and then Vim will write the content of this file into the file and also create it into our new directory. So when you exit Vim, right, and then you come back here and then you type ls, you can now see we have hello.c created. So let's go back into Vim. Let's open this file in Vim again, Vim hello.c, and now we are back here. Now we also learned about some basic commands. So if you do something like J, when you press J repeatedly, you move down the page, right? You move down the lines on inside this file, and when you want to move up, you can either press GG and then it will move you up the file, which is going to be on the first line of the file. Or if you want to move to a particular line, let's say I want to move to line 5, I can type 5 followed by a capital letter G, and now you can see it will move to the first character of this line here, which is line 5, right? So by moving, I mean the cursor, right? So you can see the first character of this line is highlighted. If I want to move to the end of this line, I can go all the way here by pressing the $sign. You can see it has moved to the end of this line. But when I'm in normal mode, when I'm in insert mode, right, I think there's normal mode and then command mode. I usually confuse these two. But when you press I, you are now in insert mode. Insert mode and normal mode. So you are in insert mode here. When you type that same $sign, it will put in the $sign there. It will not do any special stuff. It just puts in the $sign there. So if you want to move around or use Vim commands, you press on escape, and now you'll be able to do a lot of things. Okay, so quickly let's compile this code and run it to see what it does. So first of all, we need to go to the command mode, right? And then we can then put in something like this. So we'll run this command. I said the last time, if you put the $sign in front of a command, it means you want to. So this basically changes the Vim interface into a command line at this point where you put the command this exclamation mark, this is not a $sign, this is an exclamation mark, and then you begin to type your command. So you put gcc, which is the compiler for Vim, so -o, which means output hello.c into a file called hello, right? You can call it anything, right? You can call it you can give it any name. This basically means the name of the file you want your C program to be compiled into. So we just put a result. I'll just put results here, and then you can see there is an error. Cannot find such directory. What just happened? Hello.c no longer available. Okay, so I must have made a mistake here. Let's exit Vim quickly. Okay, let's save this. Okay, and then let's go out here, clear. Let me just compile. Let's ls this first of all. So we are listing the content of this directory, which is this ls here. And then let's do this. I'll say gcc-o, right? This is how you compile a C code. I will explain how the compilation process works in a bit, but let's just do this quickly. So hello.c, and then I'll still put results as the name of the file. this ld here, I'll also explain what this ld is. This a stage in the compilation process, basically the last stage, which is actually telling us that something is wrong in our code. So let's see. Sorry, vim hello.c. Oh, okay, vim sorry, ls. Something is happening. Okay, so basically what this is saying is we no longer have our hello.c file. I'm not sure why the file just disappeared, so let's create it again. Hello.c, and then I'll still type, I'll just put in, so let's go into insert mode. Here we can see hello file, hello world. Okay, hello.c, and then we'll just put this here, and then we can say here include std with this standard standard io, right? stdio.h, and then here we can now type in our function. I'll just put main void print. So I like to indent my code a little bit, so let's just put printf hello world, right? And then we can just terminate this right here. Okay, so just do this here. Okay, so all right, you can press X to delete something in your command, your command mode, right? So here, let's write this file. Okay, now the file is written. I don't know why. Okay, let's undo this. Exit. So let's quit vim, right, to be sure that the file was created. Sorry, this okay, we have hello.c here, right? The file is here. So what's the reason why it wasn't compiling? Let me see again the compilation. So, well, maybe it's because I'll be putting the output file name before the actual file name. So again, ls has this bts folder has the hello.c file, so we can do something like this. Let's say gcc-o, right? I want to call it a different name. I'm not sure if that's the reason why the file kept getting deleted. So gcc-o result hello.c. Okay, now it got compiled successfully. You can see we no longer have any errors here. And then when we do ls, you can see we have the result file here. Now the file is a bit different from this one. This actually contains the code that the machine will run, right? So when you do something like this, by the way, this means look into the correct directory and run the result file. And you can see hello world is printed here. So what I'll do here, I'll just clear this again. Okay, I keep typing the clear command wrongly. So let's open the file. Okay, let's remove the results. So you can see we no longer have the compiled version of the result file. So let's open this in vim again, hello.c, and then I will do something. So let me move to line 5. So I'll put 5 then to the end of this file. Now somebody taught me something in the comment section for my previous video from my previous stream, what I said was actually really a good trick for Vim. So I'll quickly show you the comments and try to use that command. So let's go back to the first stream, last week's stream. Open this here. So I'm just going to go to my YouTube page. Hold on. I'll show you a trick in Vim that you can use to, work faster in Vim. So basically what I got, the tip I got was that you could, so here's the comment. Let me show you the comment right here. So the person, okay, what just happened? Okay, okay. So say sometimes something nice about Vim is that you can type CI while in normal mode with your cursor in between some parentheses, and then it will delete the content and immediately set you to insert mode, right? So let's try that out and see. Anyway, shout out to what's his name, or what's the person's name, Anakin Mats. Thank you for this tip. It was really useful. I used it and it works. So when you come to this line here, let's move to so if you're in normal mode, right? I guess normal mode is when you type your Vim commands, the key combination. You can type E and move by to the next word, or just simply go like this. So I'll type H goes up, right? Okay, what's happening? I'm not sure what just happened, but I can type U and undo everything I just did. 5, I want to go to line 5. Okay, 5 capital G. Sorry about this. I'm not sure what's happening. Okay, so L will move me in between. L will move me towards the left. J is supposed to move me towards the right, right? Okay, it's working down. I don't know what just happened before. Now, while I'm in this normal mode, right, I can type CI and then parenthesis. Now you can see it automatically deleted everything, the content of that file, because I want to type something new, right? And then I can just start typing and say hello world, new output. I just put new output like this, and let me just put this here for printing a new line. Okay, we are done with this. We can type escape and go back to the normal mode, and we'll write this file, right? And then we can now compile this file again. So I'll just put the exclamation mark there, gcc what's the gcc-o. Okay, this is not what I wanted to type, so let's remove all of this. gcc-o, the name of the file we want to compile our C program into. So we'll just call it, I'll just call it hello2, and then we'll type the name of the file itself, so which is hello.c. And now the file has been compiled. We no longer have that error we saw earlier. So now we can come back here, quit Vim, right? Or we don't even need to quit Vim. We can still be in Vim and run this code. So we can just put it here like this, and sorry, okay, let's go back into the normal mode. I think we can do this hello2, and you can see hello world new output. In fact, let me just exit Vim completely and run the content, this hello file here. So we can do something like this. First of all, let's list the content. You can see hello2 is created, Although it doesn't have any extension like this one here. This one is hello.c. This one is just hello, but it contains the binary code that the computer actually understands to output our program. So let's do this. We can put here the dot and this /, and then we'll type in hello2, right? And then when you run this, you can see hello world new output in your terminal, and this has been printed onto the next line, okay, instead of having it on the same line. Now let's go back into Vim and actually understand what's happening behind the scenes, and we will understand this code line by line. So let's go to hello.c. and again we are now in Vim. Now the first line here is a comment, right? Nothing happens when the compiler sees this code. Nothing happens, it just ignores it. This is just something for yourself to actually remember what's going on. You can put in any anything into these two symbols here. It's not really a C code, right? Every programming language has comments, right? There has every programming language has comments, the comment feature, which is just something programmers use to explain, like leave hints for themselves. So this basically can be anything, it doesn't matter. In fact, we can even remove it completely. This has no effect on our C code itself. Now this line here on line 2, right, which is where we actually begin to get curious as to what is going on, right? So on this line here we can see this pound symbol followed by the include word and then some string in these brackets here. So I'll explain what this is. Let me open my file. So here I'm going to just type in a few things to explain what's actually happening here. Sorry, okay. All right, let me just plug this thing here so that I'll be able to type on the screen. Okay, now when you do something in Vim and you press U in your normal mode, it changes the code back to the content of the file back to the previous stage. So let's take this here. I'll just copy this here and impute it here. So let me just go back into, I'll delete this and increase this a little bit. Okay, this includes stdio. Okay, back to normal. Let's just make it a little bit, yeah. All right, so this is different from what I'm actually going to be doing now. Okay, so here we have this what's going on. The stroke was actually really huge. Let's see, stroke width should be like this. Okay, yeah, this is better. So here, right, this is a line for something called the preprocessor to actually understand. So before your preprocessor, we have something called preprocessor, right? Before your C command, your C file actually runs, it goes through different stages, right? Typically these are in 4 stages. The first stage being the preprocessor running, right? The preprocessor will run and include certain things into your C file, and then we have another stage called the compilation stage, right? I'll demonstrate all of this stage as we go on. We have the compilation stage, we have the assembly stage, and we have the linking stage. So this preprocessor runs and does something really special. So this include keyword means include the content of this file, right? This is the preprocessor symbol. When your C program is compiling and it comes across, I don't know how I moved it. My OBS just disconnected. I'm not sure what happened. Okay, it's back now. All right, so we can output the content of this file, right? We can see what exactly is in this stdio file. We can go into it and understand what happens, what's in it, right? So first of all, to see the content of this file, I will just type in some command that I actually found online. So we'll type gcc, right? GCC, and then we want to expand, right, -e the hello.c file, hello.c. So meaning expand the content of this hello.c and then output it into a file. Let's call this stdio. Okay, let's just call this includes.i. Now I'm not sure why we needed to put the I extension, but according to what I've read, it's a convention for actually outputting preprocessor directives into a file. So you need to put this I here. Now when we run this command, we ls it, we can see we have the includes.i created. Now what this does is it will actually output every preprocessor directives that this hello.c file is using, right? So hello.c is our program that we wrote, but in our program we actually use code written by other people, which is, for example, this stdio.h file, sorry. And then we'll see where this file actually exists on our machine, right? So when we do, I can use cat, but let me clear this. I'll use less to show the content of this file, because with less we can press some q command and then just exit it instead of having everything on our screen. So ls includes.i. So now you can see a bunch of directives are being printed in this file, and you can scroll through the content of ls as well. So one interesting thing, the one we are looking for is this stdio, this stdio.h file, which is in the user includes blah blah blah. This is where it is on our machine, right? So when we go back to let's exit this ls, this less state. To exit it, you just press q and then it goes out from there. So now what we can do is to go into this file. So we can just type here, right, include stdio.h. We can actually open this in Vim. So let's open this in Vim and see what the content of this file is. So you can see it contains a lot of code, right? A lot of things have been written here. This is a file that somebody has actually worked on and pre-wrote some C code for you to use, right? And let's look for the printf. Like I said, printf is actually from I mean, it's defined in this folder that we included in our hello.c file. So to search something in Vim, right, in your normal mode, you can just type /printf. So you can see the first result we got here, printf output for NaN, which I assume is not a number, but this is not what we want. We want the actual function definition for printf. So we can press on N to move to the next one. Oh, okay, sorry, printf and then enter. Right now we are inside the search mode, and then when you press N, it will move you to the next instance of that word that you searched. And if you want to move back upwards, you can press capital N, and then it will take you back. Now you can see we are on the line. We are on line 133. When I press lowercase n, it moves us to the next instance of the printf function. What we actually want is this function here, this printn here, right? So you can see there are some comments written to explain what this function actually does. So you can see it says write formatted output to std out, right? So whatever you put inside this function will be outputted into your command line. And then you can see this function is a possible cancellation point and therefore not marked with true. I don't understand what this is, but we can see the point of this stage is to actually understand that the printf function actually exists in a header file, right, that we actually included into our code. So the entire content of this file, this stdio.h header file, is actually imputed, right? It's actually imputed into our hello.c file. So all of this code exists in our hello.c file. So let's exit Vim. We are not going to modify this file, so I'll exit Vim by quitting Vim, and when we do ls again, you can see the includes file is here. So I'll just remove, let me just leave it now. So that is the first stage. That's what happens in the first stage of the compilation, right? So the preprocessor goes into reads your code, right? Because obviously we have a preprocessor directive here, which tells the preprocessor to go into this file, right, and output everything into our hello.c code. Now you will not see this in your code. I mean, to prove that, I will still go into hello.c, or let's use hello.c, and then you can see it just shows you whatever we wrote before. This is our comment. This is the preprocessor directive, and then here's our actual function definition to run the C code, right? So when you press Q, it will exit less, right? So now what's the next stage? The next stage of the compilation process is the actual compilation, right? This is where the normal code is actually transformed into a code that the CPU actually understands. It's called an assembly code, right? So let's see what happens, what the assembly code looks like. So I actually did some research and know a few things about this. So when we run a command like this, gcc -s, capital S, and then let's call this I'll just call this comp or compiler code, right? Or let's just click compiler stage, right? This is the compilation or compilation stage. So I'll just call this compilation stage, right? And okay, we don't need to call it anything, so we just say gcc-s, and then we put in our actual C code, right? So hello.c. When you run this, you will not see anything, but let's see what's in our directory. Now you can see we have hello.s, right, which is the compilation, the compilations processes file, right, the result of our compilation. Sorry, after typing gcc-s followed by the file, the C file that we created, we get this hello.s. You know what, let me remove it again to show you what I'm saying. So when we ls, we'll no longer see the hello.s. So let's clear this. Oh my god, I still typed clear wrongly. So let's clear this, and then we'll say gcc-s hello.c. And then when we ls this, now you can see we have hello.s. So let's take a look at the contents of hello.s. So we'll say let's hello.s like this, and you can see this is the assembly code, right, that the CPU will actually understand. So our code has been changed into the assembly version. When you scroll down, you see the contents. There's more and more stuff to read. So you can see hello world, new output. You'll not understand what is going on here, but this is one of the stages the compiler takes our C code through. All right, so the next thing that will happen, right, we'll first of all exit this last stage. So let's exit this part here. Now we've done the, okay, let me type out the different stages here. So we have the first stage, let me just put it here. Stage number 1 is the preprocessor stage. Let me just write it out like this. So we have the preprocessor. Is this processor? Okay, preprocessor stage, that's stage 1. Stage 2 is the stage where the compilation happens. So we'll put the compilation stage here, compilation stage. And then stage 3 is the stage where your code actually gets transformed into the zeros and ones that your computer will understand, or your operating system will understand. So that stage is called, what is it called again? Assembly stage. So assembly. And then the final stage is called the linking stage. All right, so we've covered the preprocessor stage, right? That's done. We covered the compilation stage, and we actually saw whatever goes on in those stage. Now the next stage we want to cover is the assembly stage, right? This is where the transformation of your assembly code into zeros and one happens, right? So your assembly code, which is in this hello.s file, let's see it again, hello.s. You can see this is the content of this hello.s file. So this file would then be transformed into zeros and ones that your computer will actually understand, right? So you will get the zeros and ones, but we will not be able to actually see the zeros and ones. But before I show you the zeros and ones, let's actually take a look at what is in our compiled version of the C code that we run here, right? So this is hello.2. So we'll say hello. Okay, so let's just this hello.2 here, hello. Okay, hello2, not hello.2. I should choose better names for my files. So you can see hello world, new output, right? So let's take a look at the content of this file. So I'll just do less, right? The difference between less and cat is that less will open like a new editor sort of and show you the content. Once you quit it, the content of that file will be removed from your terminal, instead of seeing it there again. I'm not sure if you understand what I mean. So let's do something like, let me show you the difference. So when you do cat hello.c, right, you can see it automatically quits, it automatically exits and then leaves the content of the file in your terminal. Most of the times you don't want this, so you rather use less, right? So say when you run less hello.c, right, you can see it just shows you a new instance, a new screen entirely, right? You can see the content of your file, and once you quit less, right, once you press Q, the content is gone, but you can see the content of cat is still on your terminal, it's still there. And now I'm not saying cat is useless. Obviously it's still very useful when you have to copy certain things from a file and you have to constantly switch in between less and cat. It's not really useful that way, so you should use them when you actually need them, right? They have different uses, but they all output contents of a file onto your terminal. So one leaves the content on the terminal and the other one removes it once you exit the stage. So let's take a look at the content of our compiled file. So I'll say less hello2, right? Hello2, like this. Now you can see hello2 may be a binary file. See it anyway. I'll press Y, which is yes. Now you can see this is the content of our binary file. We don't understand anything that is going on here, and it's a really huge file, right? This is something your operating system understands, but not your not you as a human being, right? This is what the compiler transforms your assembly code into, right, at the assembly stage. First of all, we had a look at the assembly code, which is the hello.s file, and then that file will then be transformed at this stage, at the assembly stage, into a code like this, into binary code that your operating system actually understands, right? So now let's exit this. So if you press Q, you'll be able to exit this easily. Now you can see we no longer have the content of the file on the screen, whereas if we had used the what do you call it, the cat command, we'll still have all of that on the screen, which is not really useful to us. So now let's take a look at what happens at the assembly stage. So at the assembly stage, your hello.c file gets transformed, right, into zeros and ones that we just showed on the screen now, and I'll show you a proof of that. So when you run gcc, right, gcc dash c, which means compilation command, right, hello.c. okay, you don't see anything happen, but a file has been created. So when we run ls, you will see hello.o, right? This hello.o is the file that will contain the assembly code. So I mean the zeros and ones that our operating system will understand, not the assembly code. The assembly code is contained inside hello.s, right? So when you hello.o, now you can see the same prompt we got when we ran less hello2, sorry. Why did I call it? I should just give this a better name instead of confusing myself. So hello2, right, is the compiled and finished version of our C program that we can run, right? But going through the different stages of this compilation, we were able to create the stage where our assembly code is transformed into zeros and ones for the operating system to understand, right? So when you say yes, you want to see it anyway, you can see the same contents from our hello2 file is also here, right? You can see everything here. It looks the same, right? It might not be the full full version of that, because there's a last stage that comes after compilation. So after the assembly, which is linking, right? The linking stage. So we'll understand what the linking stage does in a bit, but let's exit this I'll come back here and press Q, and then we've just exited the command. And then we can just ls again. You can see this is the last stage. Now the last stage, which is the linking, right? The linking is done. I've actually not found any command to see what happens, or the transformation of the linking. I guess it happens automatically when you run the gcc command, gcc dash o, right? I think gcc, okay, is it hello the file name before? Okay, it's o before the file name. So hello, when you run this hello, okay, sorry, this is the that dash o hello, right? Hello. You know what, let me use this opportunity to delete the hello 2 and then give it a different name. So remove rm hello 2, and then let's list it again. You can see hello 2 no longer exists in this directory. So we can do something like this. We can say hello, oh sorry, gcc dash o dash o, we'll just call this results, right? Results, and then we can say compile the results into, compile hello.c into these results, right? And then that's all. So now when we ls this, we can see results is here, and then when you do this results, you will see the contents of the file here. Now this is actually very interesting. Now the only stage that I was not able to demonstrate is the linking stage. Now what happens in the linking stage? Well, it's a quite interesting stage where the your gcc, the compiler, actually goes to find, you know, C library codes, right, like the printf and so on, and then find their resulting machine code, and then compiles them into the final result file that will be created, or the final executable file that will be created. So let me show you an example of this. When we type less, right, when we type less and results, yes, you can see the content of this is actually longer, and we have not even reached the end of this file, right? Now as when I keep scrolling, you see it's just endless, right? It means a lot of things is happening here, and what I suspect is happening is the content of this header file, right, this stdio that gets included in our normal C code is also being transformed into zeros and ones for our computer to understand, for our operating system to understand, which makes this file a lot longer, because that file, right, let me quit this and let's ls this, right, includes contains the file. So I'll just quickly navigate through all the commands I've run. Let's quickly get to here so that you can see, if we go down this file, okay, sorry, let's say escape, okay, what's going on here? I don't know. Okay. You are not supposed to edit this file, so we are back up now. I'll just press capital G, and then it moves you down the file. It moves you to the end of the file, the last item on the file. And you can see on this slide we have about 904 lines of code, right? And this is just for the definition of the header file, the stdio.h file, which includes our printf. So let's search for printf like this, and then this is the first let's go to the next one. I think it's this one here. Yes, so you can see this is printf, the one we are looking for, right? Let's move. Okay, so here you can see the definition here. I'm guessing everything in this file is being compiled or transformed into the binary code that our operating system will understand at the end of the day. Let's quit this quickly. Yeah, so let's take this out, and yeah, so we cannot see the contents of the linking process, which is the final file. But what actually happens at this stage, right? What happens at this stage is the transformation of all the C library code, which is whatever we just saw in the header file, plus the transformed version of your actual C code, right? Let's see. Vim, let's go into Vim again and open our hello.c file, right? So you can see this is the basic code we just written, right? And you can see the content of this file will also be transformed into zeros and ones for your operating system to actually execute the code at the end of the day. Now let's quickly do something. Let me show you something interesting that happens. So again, let me use let's move 3 words back. Let's go to the 5th line. You can press 5 and then capital letter G, and then if you want to move to the next word, you just press W, and Vim will automatically move it to the next word for you. Now when you're here, type CI and then, okay, let me just go back again. That did not work. I probably did do it well. So let's go back to the 5th line. I'll just move down and next word. CI here. Okay, CI followed by the parenthesis type, right? It could be a curly braces or a normal parenthesis like this. So when you type it and you put it automatically deletes whatever is in the file, right? And then write out a new, put you in insert mode with the option to type in new stuff. So when you come here, you put printf and then how many? Printf hello. Okay, I'm no longer going to type hello world, but I'll say preprocessor. I'll just list out the steps of compilation of a C program, right? Preprocessor, then we have compilation, and we have assembly, and finally we have the linking stage. So we can do this like this, and let me just add in a new line here just for having a nice code format. So I will exit Vim now. I will exit the insert mode and come back to the command mode. And yeah, let's write this file. Now, one thing you would expect to happen is when you run this code, right, which is going to be results, right, which is the previous compiled file that we had. When you run results, something you would expect to happen is to see the content of this new hello.word file. We'll see preprocessor, compilation, and the rest. Well, what will happen is we'll see the last code that we compiled, right? You can see hello world, new output. The reason why this happened is because we did not compile the code, right? We're just like trying to run the file again after we just changed the content, and it doesn't happen this way in C. A program like JavaScript or Python would have done this for you under the hood, and you will not have to compile your code by yourself, right? It will automatically run the compilation for you, right? That's why they are called, I think, is he I'm not sure if it's high level languages, I don't know. You don't run the you don't compile your JavaScript code by yourself. You actually run the compilation is done automatically for you behind the scenes, and then you just have to like run your JavaScript code. I can even show you an example of that right now, but by running a Python code. But we'll leave that for now. Let's actually run this code here. Let's compile this code. To compile the code, you come back here, right? Because we are typing a command, that's why I always put this exclamation mark here. Otherwise, anything we put without this exclamation mark will be a vim command, and we don't want to do that, right? So we want to do this. So we'll say gcc, always start with gcc -o, which means output into results, right? Hello.words compilation. So now you can see the compilation was successful. We did not have anything here, right? And when you go back, let's exit Vim again, Q, and then when you come here and you run these results, right? Results, you will see preprocessor compilation, assembly, and linking outputted in your terminal, right? This is what happens behind the scenes of these other languages like JavaScript and Python. But with C, right, you have to like experience and know what actually happens. If we had a mistake, right, let me show you something. If we had a mistake or a bug somewhere, our compilation process will fail, right? So let's open hello.c. Oh, okay, I just created a let's quit that. Hope the file was not created. Yeah, so vim hello.c, right? Let me intentionally make a mistake here. I'll just put X here like this. Okay, I'm in command mode. So X means delete something, right? Which is why you saw that stuff deleted. So if I type I am now in insert mode, and I can put this here. So let me just do that, and I'll also put X here to just cause some errors, right? So let's okay, let me just leave that there like that, and let me exit Vim, right? So I'll just write this and try to compile this file, right? So gcc -o results, and then hello.c. Now you can see we have an error, right? The compilation fails, which is something you would actually encounter when you are typing a JavaScript code or a Python code and you make a mistake, right? It will warn you. You don't see this process behind the scenes, right? You don't see it, it just happens. But with C, you get to experience it. You can see the compilation failed. It says no, you can't, this code cannot be compiled, right? This code cannot be changed. So there's an error. You need to read the error and then make the changes. So I'll just move and delete all of the mistakes we made. So I'll just put this back here, come back to this place. Okay, for int f, let's move here. I will press X again to delete this. All right, I guess there's no more errors, so we can just write this content and then gcc results hello.c, and now we no longer have that error. This is the previous error. For you to track what's actually going on, you can see it here. It says press enter to continue, and then there is nothing before that, right? So press enter, and then when we run our file now, we can just do something like this, and then we can see results like this, and then you can see preprocessor, compilation, assembly, and linking printed in the terminal. All right, so that's it for today. We've learned quite a few things to like get our hands dirty with C, and we understand how this process, actually run. And we can then begin to like learn the basics of C in terms of writing an actual C code. I'll suggest you read this source code. I mean this website, the content of this website is actually good. It teaches you a lot of things. I mean, I read about the preprocessor and everything here. Of course, you need additional sources. You can, go ahead and use anything that can give you more detailed explanation on this topic. You can see